All right. I will begin. Here we go. Dear Heavenly Father, we thank you for this day. Again, I thank you for this class. For these students, just ask you to just guide our steps today. Help us to glorify you and what we do. In your name I pray, Lord Jesus. Amen. What? Of course, it's like.
Oh, sorry. Just so I have to glad you stay focused. Sorry.
All right. Let me go ahead and turn the volume down just in case it's actually somebody. I think it's. I don't know. I got like some kind of. I don't know. What do you want to call it? Spam or something like that. Like a unsolicited call. What's that? Robocall? Yeah, like a robo. Well, it wasn't a robocall. It was actually from somebody in a call center, and started reading from their script, and of course I hung up as I do. But anyway, it's probably one of those. Example 1. Let us see if we can solve the following equation: natural log of 3 minus x plus the natural log of 5 minus x. All right. Equals the natural log of 50 minus 6x. All right. Can we solve this? All right. This is problem 64 from like section 4.5. Uh-oh. If you're wondering. So section 4.5 has like logarithm equation problems, okay? We've done these before, right? Let's see if we can do this one. So what should we do? I'm going to start by combining these to natural log of 3 minus x times 5 minus x equals to the natural log of 50 minus 6x. And then I'm going to exponentiate both sides. All right? So if I e to this side is e to that side, what's that give me? That gives me 3 minus x times 5 minus x is 50 minus 6x. Can we solve that? Nobody knows? Somebody must know.
I know how to solve it.
Anyone else? We should do what? We should multiply this out, right? This is a quadratic equation, right? So we've got 15.
15 minus 8x.
Yeah, minus 8x.
Plus x squared equals 50 minus 15.
All right, so this gives us x squared minus 2x minus, what's 15 minus 50? It's minus 35, I believe. So are we all on the same page there? So if we bring everything to one side, we get minus 8 plus 6, which is a minus 2, and 15 minus 50, which is minus 35. I left the x.
Plus x plus 5, x minus 7.
Oh, it factors?
Yes.
Oh. X minus 5, x plus 7. Now, what do you guys think?
No, x minus 7.
Oh, so this doesn't work, right? Because this gives me a minus 5 and a plus 7, which gives me plus 2 here. So we need to make the plus on the 5 and the minus on the 7, right? Cool. Which gives us what? X equals to negative 5, or x equals to, I heard positive 7, right? Now, as is the case with these problems, we have to go back to the original equation and check, right? Do these work? Are they extraneous? What's the situation here? So what do you guys think? So notice, notice that like 3 minus minus 5 is equal to 8, which is positive, right? And 5 minus a minus 5 is 10, which is positive. So that's good. And 50 minus 6 times minus 5 is like 80, right? So in short, that works. Like I don't have any trouble with natural log of a negative number on that one, right? But how about the x equal to 7? X equal to 7 we got to throw out, right? Because there we get stuff like natural log of 3 minus 7, which is like the natural log of minus 4. This does not exist. So that one is extraneous.
What am I doing?
I don't know, Michael.
I'm supposed to be focusing. You know what? I'll take a picture. How's that?
That sounds like a plan. All right, here's another one. Example 2. Let's see if you guys can solve this one. Here we're up against log base 7 of x cubed plus 65. Bless you. Equal to 0. So how do you solve that equation? In some sense, this is easier than the last one, right? Because it doesn't have any logarithms we have to combine. On the other hand, it's kind of harder because it's got a cube in it, right? But it's not too bad. What I would do with this equation is maybe I would exponentiate both sides, like raise both sides to this, base 7. So like this is, if I do 7 to the log base 7 is equal 7 to the 0. What's 7 to the 0? Well, 7 to the 0 is 1. And this is x cubed plus 65, which gives me x cubed equals to 1 minus 65, also known as now how do you solve a problem like x cubed equals to minus 64? Well, cube root. So the cube root of x cubed is the cube root of minus 64. And the cube root, unlike the square root, doesn't have the plus minus property. It just, that's minus 4. We just get one answer, and there it is. Right? Shall we try another?
Of course.
Okay, let's try. Let's see here. I've got natural log of e to the x. Natural log of e to the x. This is actually number 81. No, excuse me, 79. Natural log of e to the x minus 2 times the natural log of e is equal to the natural log of e to the 4. This is a very silly problem. Maybe it looks kind of scary, but goodness, if you understand your properties of logs, then this is extremely easy. What is the natural log of e to the x?
X natural log of e.
It's just x, right? This is just x. What's the natural log of e?
That minus 2.
Well, yeah, natural log of e is just 1, right? So this is minus 2 times 1, which is just minus 2. What's the natural log of e to the 4? Just 4. So this gives us x equals to 6.
Oh.
Add 2 to both.
Whoopsie.
Add 2 to both sides. Michael, you're killing me. Let's try number 81 in section 4.5, which is log base 2 of x equals to 1. I don't think we've come across one like this yet, but we should talk about how to solve it because it's not bad. It's actually very easy. What do you think we should do? Exponentiate base 2. I like that. That sounds like a good idea. So that would look like what? 2 to the log base 2 equals 2 to the 1, which would give us log base 2 of x is equal to 2. Because 2 to the something and log base 2 are inverse functions. Then what? Well, if it worked once, do it again. So we get another time, another one. That's here. So that gives me x equals 2, yeah, 4.
X equals 4. That was easy.
Yep. Let's work number 87. Number 87 gives us p is equal to P is equal to A plus
K over ln.
K over ln of x. We're supposed to solve for x. How do you solve an equation like that for x? So yeah, guys, what's coming up here? Wednesday we've got quiz 10, which is the final quiz, right? There are just 10 in here, aren't there? Yeah. So that's the final quiz, hooray! And then on Friday, I'm thinking that none of you are going to be here, so let's not have class. Does that sound agreeable?
Yes.
Yeah. All right. So.
No.
Yeah. No.
Final
He's gonna
exam.
go
Final. Just curious.
Michael, you're killing me. So, listen, Wednesday we can talk about the final exam Wednesday too. All right. Even today we can talk about the final exam if you guys got questions. Yeah.
So after test 2, we still have a class on Friday because we have test 2 on Wednesday. After next week.
Is it test 2 or is it
Test
On
3.
Friday.
test 3? Okay. I have another class which is 2 tests, so you're messing with my brain. After what? What did you say? After what?
After Thanksgiving break, test 2 is on Wednesday. Test 3 is on Wednesday.
Yeah.
You still have a class on Friday,
I think so.
and then we'll go over exam.
Yeah, we should go over the exam on Friday, and I feel like there may be a Monday after that. So we do have some review days after the Thanksgiving break still left. So, yeah. So I will, of course, offer you some video lecture Friday in the absence of a physical class meeting, you know. There are many hours of me teaching college algebra to sample from. I'll find something. So you can expect an announcement about that. But yeah, I probably won't be here Friday. I have a student giving a talk on Saturday. I need to make sure it's all pretty and done and stuff. So I haven't had a chance to really fine-tune that talk for the student yet, and I kind of owe him some hours of my life. All right, so how do we solve for x? Well, I would start out by this, like p minus a is equal to k over the natural log, right? And then I can switch these, so that gives me natural log of x is k over p minus a. Do we agree? Are you guys on board with that? Does that seem reasonable so far? Then how do you get rid of the natural log? Yeah, exponentiate. So e to the natural log of x is e to the k over p minus a. So x is equal to, if you like, we could use the exponential notation, exponential of k divided by p minus a. Or if you prefer, e to the k over p minus a. However you want to use, whatever notation you like more. I personally like the exp notation sometimes or something like this, but whatever. Any questions?
Is a question like this going to be on the test?
If you'd like.
It's really just mentioning a lot of letters and pointing them where they're supposed to be, so it's probably.
I've given Michael an unanswerable question.
Is it really? Yes. Yes.
I mean, it could be. Anything we go over in class is a potential test question. Yeah. All right, guys. So is there anything in particular in the mission you'd like me to talk about? Is there anything you guys are stuck on? Or
I'm already done with the mission.
Michael's already done with the mission. That's good. Yeah.
Did you go over problem 102?
Were you also interested in 102? Yeah. All right, just a second. Let me look it up.
Or like something similar?
102 or something similar to it. I can arrange that. This is mission 3, right? Yeah. All right, come on, show yourself. Where'd it go? Well. Sorry guys, I'm having a hard time finding mission 3 at the moment, but I will find it.
I'm having a bad day.
What if you pull up the Canvas assignment and just look at the PDF?
Well, that seems like cheating. That would make it too easy. I need to find it, like, you know, in the wild. By that I mean on my computer. It's okay. I have it on the website. I can't not find it there. So 102. Oh yeah. Sure, we could solve something like that. So example 6, kind of like problem 102. Suppose you're given something like a of t is equal to 10 minus 7 e to the minus 0.12t, all right? And then the question is to find the time at which a of t is equal to 8, let's say. I hope that makes sense. It would be, I mean, if I just make up a problem, it's conceivable I could choose a value that a never reaches. I think it reaches 8. It starts at 3 and it ends at 10, so sometime in there it's got to get to 8. So yeah, let's find the t at which a of t is equal to 8. All right, so problem 102 is kind of like that, right? Just this is the one you want, right? Okay, guys, so what should we do? What we should do is we should write down 8 is equal to 10 minus 7 e to the minus 0.12t. And then we just solve for t. All right? Let's see here. So I'd start by subtracting 10 to the other side. And that would give me minus 2 is minus 7 e to the minus 0.12t. I want to isolate the exponential, right? So I should divide by minus 7. And so that's going to give me 2/7 is equal to e to the minus 0.12t. So far, so good? Then what?
Take the natural log.
Take the natural log. Sounds like a good idea. So we've got the natural log of 2/7 is equal to the natural log of e to the minus 0.12t, also known as minus 0.12t. Because natural log and exponential are inverse functions, that's the whole reason we took the natural log of the equation. Now solve for t. So t is equal to the natural log of 2/7 divided by minus 0.12. So t is equal to approximately, for me, I mean, you could just say that's the answer, right?
10.44 minutes.
10.44? Okay. I don't know what that's about. Let's see here. Seems like there's more and more unrest in the hallways lately. They've been having a domestic violence. Well, I don't think that's got any place here.
It's like, what is it called?
I've seen something about practicing domestic violence, but I thought that would be against the Liberty Way. I'm very confused by all this.
It's like a seminar
Okay.
to not.
So to not, we're against domestic violence is the thing, right?
Yes.
What if your wife is evil?
Is your wife evil?
Well, what if your wife was about to murder your children? Then domestic.
That's considered abortion.
No.
Yes.
Okay. All right.
Abortion. It's when a mother kills.
Michael, we're not real.
Michael's not wrong.
Well, I mean, I don't think he's not wrong, but we're not religious.
So there's 102. All right. How about next? What's next? Well, I mean, I gave this example to my Sunday school a few weeks ago. We were in Romans 13. I was trying to give them an example of a place where they should defy my authority as a father, right? I gave them the example that if I was about to, hack their little brother Benjamin to bits with a sword, then I should hope that the older brothers would intervene and stop me, right? So, and then I asked the question, by doing that, or by not doing that, would they have been sinning? And would I have been stopping them from spreading the gospel message? The answer is no, right? There are times when we should defy authority even when it doesn't pertain to the gospel or us sinning, simply because we should do the right thing and defend the innocent. Just a thing to think about. So anyway, example 7. Because sometimes there's a version of submission to authority which is taught sometimes in church these days, which is just not right. It's too simplistic. It doesn't have to just be about you sinning. All right. So what was the next, guys? What did you guys have a question about? Yep. 104? 104? Well, so here I think I pretty much worked this one in class already. I like a 20 instead of a 10, but
I
it's,
think Michael might have asked that.
yeah,
Oh, I just saw that 2 days ago.
yeah. Other questions? I'm just kind of bored of 104. Sorry. No.
How many questions are there?
Well, it stops, it becomes review after copy.
Yeah.
70.
Problem 70?
Oh, Tau.
Problems. 70's in mission 2.
70 is in mission 2. This one's
Add 5. You want 75, right?
Yeah.
75. All right, so here, we're given a function asked if it's a one-to-one function. We're supposed to either use an algebraic or graphical argument to decide the question. So I'll do something like it. Maybe the square root of x minus, I don't know, 9. And I'm thinking that's not the example, but it's awful close. All right. So there are 2 ways to go about this. The one way would be graphical. So here's a graphical solution. And the question that's asked is this one-to-one?
It is.
So a more robust statement of my example that I was giving a second ago is that we should always defy tyrants. What's a tyrant? Somebody who's exceeded their God-given authority in whatever position that they're in. Anyway, I digress. Graphical here, so we have the square root function, and where does it start? Well, it starts at 3. It's like half of a parabola, like this. So there is a graph of this, yeah? So what it is the square root function shifted, I said 3, I should have said 9, right? It shifted 9 units to the, like this point right here is 9, 0, right? But anyway, there's the graph. Does this pass the horizontal line test?
Yes, it does.
It sure does, right? So passes horizontal line test. Thus, 1, 2, 1 function. That's one way we could do this problem. Another way we could do this problem would be algebraic, right? And how would you do algebraic? Right? Suppose f of a is equal to f of b. That would tell us that the square root of a minus 9 is the square root of b minus 9. And then what could we do? We could square both sides, right?
Yes.
And when we did that, that would give us a minus 9 is equal to b minus 9, right? And thus a is equal to b. So, yep. So if you can say f of a equals f of b implies a equals to b for arbitrary a and b in your domain, then it's a one-to-one function. So thus f is one-to-one. And what's the good of a function being one-to-one?
The inverse function is also 1-to-1.
The inverse function is also one-to-one. Well, that's kind of it. So sometimes I've asked you guys, find an inverse function if it's possible. When is it possible to find the inverse function? When the function's one-to-one. So let's find the inverse function here. How would you do that? So this is past the, so that was problem 75, right? We're working on problem 75, more give or take. And at the moment, I'm moving on to a question that's beyond that. But I think it's a good problem for us to try. So how would you find the inverse function to this? Now let's talk about the domain and range of the inverse function. Oh man, did I ever? Huh. Did I go back here and adjust the camera? I can't remember. I think I did. All this domestic violence today, it's very scary. Let's see here. Let's see here. All right, so let me erase a little bit here. So how do we find the inverse function?
Start off with y equals x minus.
Yeah, I guess start with the formula. Y equals the square root of x minus 9. Then what? Solve for?
X.
Solve for x. So we have y squared is the square root of x minus 9 squared, which is x minus 9. So apparently x is equal to 9 plus y squared.
Are we saying this is example 9 or just continued?
Example 7 continued, I suppose. And so then f inverse of y is 9 plus y squared. Right? And this was for f of x equal to the square root of x minus 9, right? So my question to you is, what's the domain of f? Nine to infinity, right? 9 included to infinity. And that would be the range of the inverse function. And what is the range of the function? Yep, 0 to infinity, which you can see from my graph, right? And that's equal to the domain of the inverse function. Now that's a little bit tricky here, right? See that? If you just looked at the boxed formula, what would you say the domain is? I think most of us would be tempted to say that the domain of the boxed formula right here is all real numbers, right? The tricky part here is that this only serves as the inverse function if we restrict the domain just to positive or non-negative numbers, I should say. Here's a picture of what's going on. So we've got the graph of the function, right, like this. There's y equals the square root of x minus 9. You got your line y equals x, right? So what's the graph of the inverse function look like? The reflection across that line, right? So this point, which is 9, 0, flips up to this point over here, which is 0, 9. And let's see here. I think it does. I'm trying to picture it in my mind. What happens then? Let me get another point. What's another point here? How about like, I don't know, 10, right? This would be what, 10 comma 1. So we go to 1 comma 10. So it's like up here. Right, so yeah, like that. So there's y equals x squared plus 9 for x greater than or equal to 0. That's y equals inverse, y equals f inverse of x up there. It's only half of the parabola that serves as the inverse function. So do you guys have any other questions? I guess one thing I haven't talked to you guys much about yet, and I really don't have much more to say in here, because we live in a time of calculators and so forth, but you might ask the question, why did we introduce, excuse me, logs to begin with? You know? Like why introduce a logarithm? What's the great advantage of logarithms anyway? Well, let me point out like a calculation to you guys. Suppose you have, I don't know, 3 times 10 to the, well, let's see here, I don't know. Fine, 3 times 10 to the 17th. And you're taking that, right? And then you're, I don't know, dividing by, 4.62 times 10 to the 11th, right? So in terms of direct computation, that's kind of a pain, right? But what happens if you take the log of this? You get what? You get like log of 3, right? Plus the log of 17 minus the log of 4.62 minus the log of 10 to the 11, right? Which is just what? That's just the log of 3 divided by 4.62 plus 17 minus 11, which is the log of 3 over 4.62 of, let's see here, what you got? Plus 6. So if you could look that up, right? If you could look up the log of small numbers, right? On a table, yep.
Shouldn't that log in the top equation where it's 17 be 10 to the 17?
Oh, yeah, thank you. My bad. Yes, thank you. I'm a dummy. I made a correcting mistake in the next step, so hooray. But anyway, the point is you could calculate what's 3 over 4.62, right?
That's pretty good.
0 point, I don't know, what is it? You got, how many of these do you put in there? Like 6? So what's 6 times that? 3. I don't know. 2.28, 0, and so forth. All right, so essentially this is approximately log of like 0.6 and plus 6. And if you could calculate the log of 0.6 approximately, then you could, whatever that number was, say, oh, okay, so then this says that 3 times 10 to the 17th over 4.62 times 10 to the 11th, it's actually equal to whatever this number was, right? Log of 0.6 times 10 to the 6th, right? I mean, which of course you could also figure out from just direct manipulation of the numbers that were there. But the thing is, there are these things called log slide rules, right? So like my parents, not like your grandparents, maybe your great-grandparents, I don't know. It's been a while. They have these things called slide rules, and you can mechanically calculate logarithms with the slide rule. And so then you were able to like calculate logs with mechanical rulers, essentially. And so you could approximate these kind of scientific calculations. Now the other thing is, if you introduce a log variable, it takes really big numbers that are really separated. Like, check this out. This is really the reason. If we take log of 10 to the 10, and we take log of 10 to the 5, well, that's log of what? 10 billion, right? And this is log of, what was that, 100,000? Yeah, 100,000. What's the log of 10 billion? Well, it's 10, right? What's the log of 100,000? It's 5. So we can compare 100,000 to 10 billion just by going from 5 to 10 using a log. This is relevant because there's things in nature that are like this. For example, how much brighter do you guys think the light is in this room versus the light outside? Like if you could go to the interior hallway where there's no sunlight, how bright do you think it would be? Like what's the intensity relatively speaking? Like how much brighter do you think it is out there versus in here? What do you think the difference is? 3 times, 4 times, what do you think? 4, maybe 4 times, double? Something like 10,000 times brighter outside than inside. So that's why logarithmic scales are useful, is because we have eyes that can go between very, 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 very dim light and very, very, very bright light. We can see in both. The same with our hearing. We can hear very, very faint things and very loud things. And so a decibel scale, which is based on a logarithm, is useful because it compares things of vastly different magnitude using a log. But anyway, I don't really test on that because those problems are super confusing and based on like very, very weird conventions. And so I've just found it's not helpful to you guys to make it part of the course. So my apologies if I don't test on what I just said.